Hi everybody and welcome. Today's video we're going to be talking about dimensional analysis as a ways to convert units. So your goal after watching this video should be able to comfortably convert between different unit factors using dimensional analysis. So to start off with actually a couple of fun examples of unit conversions and why this is an important skill and a useful one. I actually have a picture of a horse here, and a traditional way to measure the height, I think, of a horse is by using hands. So actually, in this case, hands are a unit, and we're going to see it looks like this horse is about 7 hands tall. So way back before, probably they had tape measures and, definitive concrete ways to measure a horse, they would use hands to see, how big is this horse that I'm getting, and based off of those hands, what is it worth? And I actually do believe now hands does have like a value in inches as well. So that is a way to convert units of measure, and one of an early example of different units of measure and an early example of trying to standardize those things so that we can understand that. So horse hands is one example that we could be converting with. A second one, this is actually what made me think of it as well in a more modern example. When I was in college, I went to college in Boston, and going to New York City from Boston is actually only a 4-hour drive. So you could take a bus there, and it would, if anyone's heard of Megabus, it would sometimes cost you to have these specials. It would be like $5. So for $5, you could go to New York City for the day. And the bus station was just kind of like, so you get dropped off in one place and you'd have to pick it up in another place. And obviously when you're walking around New York City, you're having a good time, you're going all over the place. Looking at Manhattan here, I think our bus station, it wasn't actually a station, the Megabus would like pick you up randomly on the side of the street. We get picked up like where this X is, maybe somewhere over there. And, maybe if we're walking there from, I don't know, maybe we were at Grand Central taking a look at the ceiling there. So we exit Grand Central and come out right here. So we're trying to get from here, from this X to this X. And, I'm walking with my wife and, we have to catch our bus. Otherwise we're stuck in New York City for a while until that next bus comes, and that's not a fun day. So a measure in the city of distance is actually blocks. So instead of talking about like miles, if you're walking, a lot of times it's like, oh, it's only 6 blocks away. So we thought that this would be an easy walk because we started off and we're like, okay, if this is only 8 blocks away, here's 1 block, here's 2 blocks, and those went by quickly. Look at how small that is to get from the X to the first corner to the second corner. So a city block, you're basically going from one intersection to the next intersection on the grid. So those first 2 blocks went super fast. That third block is a little bit longer, and we were walking for a while on the 4th block, and I was like, oh my goodness, this is like a mega block. It's huge. It took forever. So we're seeing that all of these blocks to get from Grand Central to where we were trying to meet our bus on the corner, they're different, right? And it takes different amount of time to walk there, to travel, and that's something to think about with these unit conversions is that, especially with horse hands, like my hands might be a different size than your hands. That first block is obviously a lot shorter than the 5th block. So an important thing that we've hopefully become more standardized over time and kind of have a better understanding of what things actually take in terms of having some inconsistencies there. So some real life examples of some inconsistent units of measure. And today we're going to be kind of focusing on our math context with dimensional analysis for some more like scientific and specific and precise units of measure here. So our definition for today is also our skill, dimensional analysis. So this is when basically it's a method of using equal quantities to convert units. So a classic example is, hey, I have, 20 inches, and I want to know how much that is in feet. So dimensional analysis, instead of taking this intuitively and doing it in our heads, we can start off with 20 inches, and then we actually use conversion factors here. So we know that there are 12 inches in 1 foot, so 1 foot and 12 inches are equal. So we can actually multiply by that 1/1 quantity here and put 12 inches here and 1 foot on top. So by setting up a question like this, where we have units that cancel top and bottom, we are actually able to get to 20/12 feet as our only unit. So that's how dimensional analysis works, is we're basically canceling units and lining up our multiplication problems carefully to do that. So first, we have to determine our beginning unit where we start and our end unit where we end. So up top, we started in inches, we want it to end with feet. Next, to get there, we have to determine each conversion factor needed. So for example, to go from inches to feet, I needed to be able to cancel out inches. So I had to have inches in one of my unit conversions, and I also had to have feet in another conversion. So by doing that, by having inches and feet in my conversion factor, I got to where I wanted to go. And then finally, we want to write our multiplying expression so that units cancel. So I had to have 1 inch on the top and 1 inch on the bottom. That way we can, again, have those two quantities cancel out for us. So a few examples here. Inches to miles. This one might take a little bit longer because we have a couple things that we need to do. So a list of common ones we might use are up top here. So 5,400 inches is where we start. We know that inches are on top, so we also need to make sure we have inches on the bottom. But what's something that we can convert inches to that might help us with miles? Because eventually we need to get to this factor over here that has 1 mile on the top. So filling in the blanks, basically getting to that goal of 1 mile, we have to have 5,280 feet on the bottom. And if there's a foot on the bottom, in order to cancel that foot out, we need to have that on top. So we can use that to actually fill in the rest of our conversions here. So let's color code this so we can see 1 foot on the top and the bottom, so those both cancel. Inches on the top and the bottom, so those both cancel. And we're left with, in green, the mile unit, which is exactly what we want. So when we write this out, again, inch units cancel, feet units cancel, and we're just left with the final term in miles. So multiply everything on top. So 5,400 times 1 is actually just 5,400. And then on the bottom, we have to multiply everything as well. So 12 times 1 times 5,280. And we're left with here 63,360. So we can divide this out to get our full final answer, and we'll get here 0.85 miles. Or I wrote that wrong, I apologize. Got to be careful here. We have 0.085 miles. So being careful with those decimal points when you're writing these answers. All right, so that's an example of something that we're looking for there. Again, going through carefully with our dimensional analysis. So we start with inches on the top, and our goal is to go from inches to miles. A second type of question that we might see here is like number 4. We have 36 centimeters per 1 second. That's how that looks. So centimeters per second is centimeters over seconds, and we're trying to get to something miles per 1 hour. So we have to convert both our centimeters and our seconds here. It might be actually take a few conversion factors. So first, let's start off with some useful information we have about centimeters. We have 2.54 centimeters equals 1 inch. We know that 12 inches equals 1 foot. And we know that also, got to make some space here. We know that there are 5,280 feet in 1 mile. So we successfully got to miles. And again, let's highlight what we have here. So centimeters cross out, inches cross out, feet cross out. So we're left with miles. Now we need to change our seconds into hours. So we know that there are 60 seconds in 1 hour. And finally, there are, 60 seconds in 1 minute. I apologize for misspeaking there. And there are 60 minutes in 1 hour. So again, let's take a look at what we can cross out here. Seconds on the bottom, cross out with seconds on the top. Minutes on the bottom, cross out with minutes on the top. And if we do all of this math correctly, we can see here that we'll be left with just miles and hours. So again, cancel centimeters, cancel inches, cancel feet. We can also cancel seconds can cancel our minutes, and we're just left with miles on top, hours on the bottom, and now we just need to do our full multiplication problem to get the answer. So on top, 36 times 1 times 1 times 1 times 60 gets us to 129,600 miles. And then on the bottom, we have 1 times 2.54 times 12 times 5,280 times 1 gets us to 160,934.4 hours. So that whole division problem will get us our miles per hour, and we'll see that final answer there. So to fully do this out, and we'll get all the way down to our decimal here with our calculator, we should get an answer of 0.81 miles per hour. Before we go on, always a good idea to go through and just kind of think through this out loud and check your work. So 36 centimeters over 1 second. So we convert centimeters here using inches, convert inches to feet, and then convert feet to miles. And then finally convert seconds to minutes, and then minutes to hours. Gonna double check the calculation to make sure I didn't make any mistakes typing this into the calculator. We do verify 129.6 on top, and then on the bottom, again, carefully verifying this because I don't want to make any mistakes again. It looks like we are good with 160,934.4. And one final check. Let's plug this in and check that final answer at 0.81 miles per hour. And it looks like we're good. So double checking everything, always a good idea, especially with so many calculations here. So number 4 is definitely on the more challenging side of things that we're going to see, but the process is the same. We're basically trying to get one of the same unit on the top and the bottom to cancel, and we want to be left with the units that we're looking for. So something like miles per hour, for example. Awesome. So any questions as you're going through, finishing up 2, 3, 6, and the 9th question there? Definitely let me know. Thanks everyone for watching the